We keep hearing a lot about inflation. An inflation of energy prices, household goods, industrial products, and the list goes on. Another trend for many decades has been another kind of inflation though, an inflation of complexity in the systems we rely on to keep the modern world running. And that ever-increasing level of complexity keeps causing completely unforeseen problems whenever there is any kind of disruption. And I think we have all seen that in the form of unexpected shortages over the past few years. Under these conditions, it would be foolish to make any kind of concrete prediction about the future. Well, but for the one prediction that we will see more of these failures and problems popping up as complexity keeps increasing. This general trend is also reflected in the way products are made. As we produce products with ever more features, we also create ever more points of failure. That is one reason why many of the older items among the many finds throughout the series have survived as long as they did. They were planned and realized to perform well in a very well-defined, limited function. And I'm sure today's episode will allow us once more to compare things that were made over the course of several decades. And with that in mind, take a look at what I got for you today. These big pulleys here look amazing. Check their size by comparing them to that bicycle wheel. And down in this container for mixed copper scrap is this black transformer. And I already have a specific job for that in mind. This old Grundig radio must have been beautiful once, but unfortunately it's in really bad shape. I also found this metal enclosure though, and we will need that later today. But frankly, I don't see that many things here today that catch my interest especially. But hey, here's good news for those of you, and I know you are many, who don't have access to scrapyards anyway. The reality is that in this throwaway society, things can be found everywhere. And some of the items we're going to repair today are going to come from a rather unlikely place. On my way home, I also saw this pile of trash on the street and took some of it home. On top of that, the ultrasonic cleaner is broken and needs to be fixed. Additional items that we'll also take care of is this Japanese Luxman brand amplifier and this Fluke scope meter. So let's not waste any time then and start repairing. A device that we have used many times throughout earlier episodes is this ultrasonic cleaner. It worked well until recently. Well, normally after setting the timer, you can hear a buzzing sound as the ultrasonic emitters kick in. You would also see ripples forming on the cleaning fluid's surface. But that doesn't happen anymore. The neon lamp turns on and maybe it even still heats up, but there is no ultrasonic cleaning going on anymore. Looking inside, we can see the ultrasonic transducers that are attached to the stainless steel basin of the cleaner and also the circuits that drive these transducers. At first glance, there is no obvious damage, but this fuse here has blown. The glass tube has even basically exploded. Only the metal caps remain. Now here we are at a point where many people would just insert a new fuse and hope for the best, but that is wishful thinking. When a fuse has blown, and as in this case rather violently, there must have been a short circuit, and that is not just going to go away by itself. But for the sake of showing that this is often pointless, I have still inserted a new fuse, just to demonstrate this. And there it has popped again. The fault is clearly somewhere else, and from past experience I expect that the power MOSFETs that are attached to the heatsink are probably faulty. I connect a semiconductor tester to the 3 leads of the transistors, and it reads a short circuit on all 3 terminals. Now, it is true that it's often better to test components after removing them from the circuit. Otherwise, you might get faulty readings. But even measuring in circuit, a short circuit between all 3 leads of any transistor is usually a clear sign that it's broken. My suspicion is that the same thing happened here that happened in an earlier episode. The hot water in the basin evaporated and the device overheated because of lack of water, and eventually the MOSFETs overheated as well and they were then permanently damaged. After removing the old ones, I install new ones. And I said this before, but these insulating rubbers here, at least according to the manufacturer, work just fine without additional thermal compound. So after putting the enclosure back together, let's see then if it works again. A while ago, a friend gave me this Fluke scope meter. It's basically an oscilloscope and a multimeter in one. Unfortunately, some of the buttons, like the one for measuring resistance, as well as the time adjustment button and some others, do not react anymore. Upon opening the enclosure, I can see no visible damage. There is an old battery, and since this meter is from '95, I'm replacing it. After removing the rubber touchpad, I'm using this single soft button here that I salvaged from another device to test if I can make contact. Unfortunately, it's the same buttons that don't work. It's not a problem of the rubber part then. And here is the actual contact pad that is lying under the rubber buttons. I can see no damage, and even after cleaning everything thoroughly, the same buttons still don't work. So I looked online for a replacement part for the pad, since this is a part that is in my opinion almost impossible to repair. Luckily, I found someone, apparently from Bulgaria, who has replacements for sale. And I already installed the replacement part. It's not original, here in dark blue. And, well, the flat flex cable is a little too long. But luckily, it does what it's supposed to do, and the scope meter is working properly again. This was an easy fix, but I'm sure you will see this device again in many future episodes. Remember this pile of trash out on the streets? It's mostly cheap DVD players and a broken printer, and even though I try to repair as much as I can, even I have to live with the reality that the demand for these things is incredibly low at this point in time. Love it or hate it, a decent sized Bluetooth speaker though is in high demand, so let's see what's wrong with it. When you carry it around, you can feel and hear that something heavy has gotten loose inside and is moving around when you tilt the speaker. But before doing anything else, I remove all the old stickers, and I do that using a plastic scraper and a hot air gun. The remnants of the glue are easily wiped off using penetrating oil. Next, I want to take the enclosure apart, but I'm sure some of you have been here before. The screwdriver is simply too short to reach the screws. If you have ever tried opening a typical 1990s cassette player or boombox, you might have encountered this problem before. Long story short, I had to go to a hardware store. Too short. Also too short. Now that's more like it. After opening the box, the secret of the loose, heavy object is lifted. This magnet has fallen off the back of the big speakers. On the back side, we also find a small switch mode power supply that apparently also acts as a charger for a lead-acid battery. And I'm removing the battery since I'm pretty sure it needs to be replaced. Upon unscrewing the loudspeaker, we can inspect it more closely. The magnet was shaken off rather violently, I must assume. But there is a way to reattach it, I think. I first widen the holes by drilling them to a slightly wider diameter. After removing the iron filings, I can snap the magnet back on, but it won't hold by itself. We have to glue it in place as well. Like so many times before, I use MS Polymer for that. Probably no site for audio files. But hey, this is a cheap Bluetooth speaker from Aldi. While the glue dries, I'm checking the battery. It's a 12 volt, 4000 milliamp hours lead acid battery, but it is discharged to an open circuit voltage of little more than 3 volts. Fortunately though, this form factor is very common, and I was able to get my hands on a replacement within 2 days. Looking at this PCB, it is rather obvious that this is a Class D amplifier. Otherwise, you would see much bigger heatsinks in an amplifier with this power rating. Also, the little pot coils are typical. The presence of the integrated circuit TPA3118 confirms that suspicion. So I proceed by gluing the foam pads of the old battery onto the new one. And I insert it into that small compartment, followed by soldering and heat shrinking. The loudspeaker is also screwed in and the wires are resoldered. Time for a test then. So one of the items we found today is this transformer here. But what are we going to use it for? Well, let me show you. It's the year 1984. And a small town in the southwest of Germany is redeveloping its inner city. One of the tenants is a newly founded dental practice run by the man who would later become the father of my girlfriend. The practice would become an institution in that town and is still well known today. Unfortunately though, in 2019 that man passed away, and after his death the practice struggled to find a successor, like many dental practices around the country. It was a complicated process, but to make it short, in the end it had to close for good. Much of the equipment, though, that was installed there in 1984 was still in use in 2019. And some of it was saved, and among those items was this dental lamp here. I could actually make good use of a lamp like that at my workbench, where I often have to look inside enclosures or small openings in mechanical parts, and a lamp that could be moved around like that should actually be very handy. This lamp, which by the way was built by Siemens, was originally suspended from the ceiling, as you can see here, and on the day when the opening of the practice was apparently celebrated and everyone looked incredibly 80s and incredibly German, the lamp was also there. So, considering that my girlfriend was clearly not happy about the fact that this place no longer existed, I thought it would be nice if at least a small part of it could somehow live on in my workshop. Since the ceiling there is way too high though and not rugged enough to hold the lamp, I decided to fasten it to the OSB wall behind my workbench. In order to make that possible, I first needed a short piece from a square steel tube that I cut off with an angle grinder. In the next step, I used my drill press to drill 2 holes through it, and in the meantime, I had also printed this plastic core here in a 3D printer that will be inserted into the steel tube. And then the aluminium tube that connects to the lamp's arm will be inserted here. In order to attach that assembly to the wooden structure behind my workbench, the steel tube needs to be connected to a piece of steel plate though. but in order to be moved around freely, there needs to be a little bit of space between the wall and the pivot point of the arm. That's why I'm using these two T-shaped parts as spacers between the plate and the square tube. The origin of these pieces of stock, you guessed it, the Scrapyard. And after everything has cooled down, I'm using an M10 bolt to fasten the aluminium tube to the steel part. And here it was again really handy to have a 3D printer, because it would have been much harder to just find a steel tube that fits around that aluminium part perfectly. In the meantime, I have bolted the steel plate to the OSB panel, and the panel might look a little shaky here in this footage, but it's reinforced with 2x4s on the back side. Believe me, it's stable enough. The arm is reattached, and then a big retaining ring holds the arm on that aluminium tube. And as I'm demonstrating here, you can reach practically every spot on the workbench, as if it were made for it. But we still need a power supply for the lamp. It doesn't run on the mains directly. It has a 24-volt halogen lamp. And this is where that black transformer we found on the scrap will come into play. The writing is a little faded, but it simply has two 12-volt secondary windings that we can simply connect in series. And now we can attach a wire leading to the lamp to the two outer terminals. As you can see here, it still works and also emits a really friendly warm light. But of course, a transformer with open, non-insulated contacts is not a good idea to have on the workbench. And for that we can use the little steel breaker box we also found on the scrap. Since this enclosure was open on its top side, I cut a piece of aluminium scrap to the right length and bolted it on top. I also drilled a hole for the 12-volt wires. The enclosure was then fastened to the wall behind it, and the transformer was bolted to the box. And then all electrical connections were made, including protective earth. And another nice thing about the lamp is that when you don't need it, you can swing it to the side and have it sit there in its place without taking up much space at all. And there you go, the lamp's new home. May it have another 40 years of life. I have a little announcement to make, by the way. I will be traveling the UK around mid-October. I have been invited to a conference that I will attend in Nottingham. But after the conference is over, I will drive to the region around Canterbury, and I will meet with other YouTubers and tinkerers in England. From the 17th to the 20th of October, I still have some free time. So in case you want to meet, show me something you're working on, or just have a cup of tea, send me an email at inventordonations@gmail.com. I probably won't be able to make it further north than Nottingham or drive as far west as Wales, but other than that, I'm still open to driving around the country and meeting people. I think this could be fun, so don't hesitate to send me an email. As you can see, I have already started to inspect this audio amplifier here. I often find vintage audio gear at my visits to various thrift stores, and this time I've got my hands on a very rare specimen. It's a Luxman L308 built in Japan in the late 70s. In terms of looks, it's still in pretty good condition. The knobs are really nasty though and need to be cleaned. But unfortunately it has some technical issues as well. I have connected my laptop to one of the inputs and feed a sine wave into the amplifier. There is a phase shift between the left and right channel, but that phase shift is also in the input signal, so that's not a fault of the amplifier. But there are two other issues. You can hear and see the distortions. On top of that, there is a jitter superimposed to the sine wave, and I think that that is caused by a noticeable ripple in the supply voltage. So after pulling this unit here out of the enclosure, we can identify typical components of a 1970s stereo amplifier. The mains transformer, which is also shielded, then connected to this board in the middle here, which would be the power supply board, which has a bunch of fuses on it and also a bunch of electrolytic capacitors, and which is also hooked up to these rather bulky electrolytic caps here. And we can see that they are connected to each other with a black wire leading from them to the board. And I'm pretty sure that this is the common ground and that we have a negative and a positive rail. Now, and then of course we can see that the contact on the positive rail has corroded, which probably, not probably, but certainly means that this capacitor here has to be replaced because fluid has leaked out from the inside. It still works, otherwise we wouldn't have been able to use the power amp. And I suspect that the jitter we saw on the oscilloscope screen is caused by the failing capacitor. So I proceeded by removing them from the enclosure. I also measured the capacitance and the ESR. Going by the values, the capacitors would still appear to be within spec, but I'd say it's rather obvious that there is an issue here. As a replacement, I have ordered these electrolytic caps here that are also rated at 10,000 microfarads at 63 volts. It might look a little empty in here after replacing the caps, but that is just the technological progress of the past 45 years. You simply can manufacture caps of the same ratings now at much lower volume. In order to deep clean them, I'm pulling off all the knobs. The volume pot is also detached from the front panel, as it will have to be replaced. This component consists of 4 individual potentiometers on one common axle. And this is rather unfortunate, since it will be almost impossible to ever find an exact replacement for this pot. Past experience have also shown that in most cases it's not really an option to restore the potentiometer to its former functionality in a satisfying way. Getting them back together after taking them apart is hard enough, but then it's still not said that cleaning the pots will even do anything, as the fault might be the cause of wear rather than dirt. In the meantime, the knobs are suspended in warm water with ordinary washing powder. One could use the ultrasonic cleaner here, but I wanted to show that you often don't even need that. We let that sit for a while and return to the potentiometer. Since I wasn't able to find a replacement for the original 4-channel pod, I have to help myself out by other means. I have this stereo potentiometer that I solder on a little piece of Vero board, where I also add a few resistors. But how can 2 pods replace 4 pods? Well, let me explain. The designers decided to integrate the balance control and volume adjustment into one component. That's why there is an inner and an outer knob here, and essentially 2 axles that can be turned individually. The user manual even explains this feature. So what I'm doing here is to replace the balance control pods with 2 fixed voltage dividers. This means that I will no longer be able to adjust the balance manually. But balance only means that you can decrease the volume of one channel selectively. And when I use this with my computer, I can't just adjust the balance there, if I even ever need that. More importantly, the volume adjustment will work again. Maybe one day I will find a better replacement, who knows. As you can see, with the new caps and the replacement pod, the jitter is gone and the volume adjustment on both channels works again. In the meantime, the caps have been glued to the enclosure, and we can take another look at our knobs. Before and after. As you can see, simple washing powder can often do the trick. In order to stabilize the rather wobbly plastic axle of the replacement pod, I also 3D printed this little guard that will restrict it a little bit so that the volume knob will have a better feel to it. And after putting everything back together, let's play a little music then. So I hope that you liked what I had to show you today, and it's important that you give the video a thumbs up if that was the case, telling me to keep on producing videos of this type. And if you want to help out even more, you can make a donation via PayPal. A link for that is down in the video description, or become a supporter on Patreon under patreon.com/tpai. See you soon.